Welcome to our journey through the cosmos, where we explore the ultimate fate of the universe. The universe began with the Big Bang, an explosion of energy from an infinitesimally small point, birthing space and time itself. But how does it all end? Today we'll delve into 8 fascinating theories that scientists have proposed to explain how our universe might end. These possibilities range from the cold, slow death of the Big Freeze to the cataclysmic collapse of the Big Crunch. Fasten your seatbelts, fellow space explorers, as we embark on this exploration of the universe's ultimate destiny. Our first stop takes us billions, even trillions of years into the future. That's a lot of candles on the birthday cake. Imagine a universe where the once bright stars have exhausted their nuclear fuel, leaving behind only cold, dark remnants. Like a cosmic fridge with the light off. This is the essence of the Big Freeze, also known as the heat death of the universe. Sounds like a bad sci-fi movie, right? The universe is constantly expanding, pushing galaxies further apart. It's like the ultimate social distancing. As this expansion continues, the energy that fuels the universe becomes increasingly diluted. Like trying to make a cup of tea with one tea bag in a swimming pool. This relentless expansion has a profound consequence. The universe gradually cools. Time to break out the cosmic sweaters. Stars cease to form, galaxies become islands of darkness, and the universe descends into a state of maximum entropy. It's like the universe's version of a really long nap. In this scenario, the universe reaches a point where everything is so spread out that no meaningful interactions can occur. Talk about a long-distance relationship. No new stars can ignite, no new planets can form, and the universe becomes a cold, dark, and desolate place. It's like the ultimate ghost town. The universe, in its relentless expansion and cooling, seems destined for this slow, drawn-out demise, a cosmic snooze fest, if you will. If the Big Freeze is the universe slowly winding down, then the Big Crunch is the universe suddenly slamming on the brakes and throwing everything into reverse. Imagine the expansion of the universe slowing down, halting, and then reversing, pulling everything back together. This dramatic turn of events hinges on a critical factor, the density of the universe. If the density of the universe is high enough, then gravity becomes the dominant force. Instead of continuing to expand forever, the universe would begin to contract. Galaxies would draw closer together, their cosmic dance now a slow waltz toward an inevitable collision. As the universe contracts, it also heats up. Stars would be squeezed closer together, their interactions becoming more frequent and violent. Eventually, the contraction would reach a crescendo, a point of unimaginable density and temperature, where stars, galaxies, and even atoms themselves would be crushed together. This is the Big Crunch, the collapse of the universe into a singularity, a point of infinite density and temperature. Our understanding of the universe took a dramatic turn in the late 1990s with the discovery that the expansion of the universe is not slowing down, it's speeding up. The culprit behind this cosmic acceleration is a mysterious force we call dark energy. The Big Rip is a chilling scenario where dark energy ultimately tears apart the very fabric of the universe. Imagine a force so powerful that it can overcome the fundamental forces holding matter together. In this scenario, the expansion of the universe continues to accelerate, driven by the ever-increasing dominance of dark energy. As the expansion accelerates, so too does the rate at which galaxies are pulled apart. Eventually, the expansion becomes so rapid that it overwhelms the gravitational forces holding galaxies together. Galaxies are ripped apart, their stars scattered like dust in the wind. As the expansion continues to accelerate, it begins to affect larger structures, tearing apart star systems and planets. Finally, in the final moments of the Big Rip, the very fabric of space-time itself is torn apart. Chapter 4: The Big Bounce, a Universe Reborn. Throughout history, cultures across the globe have pondered the concept of cyclical time, the idea that time is not linear but rather a repeating loop. This concept finds a fascinating echo in the Big Bounce, a cosmological model that envisions the universe as a cycle of expansions and contractions. Imagine the Big Crunch we discussed earlier, where the universe collapses in on itself. But instead of marking the end, this singularity becomes the seed for a new beginning. The immense pressure and heat at the singularity ignite a new Big Bang, creating new space and time. the universe begins to expand and cool, eventually forming galaxies, stars, and planets. This cycle of expansion and contraction could repeat endlessly, each cycle potentially giving rise to a universe with slightly different physical laws and constants. Our universe, in this model, is just one iteration in an infinite chain of universes. Chapter 5. False Vacuum Decay, the universe unraveling at the speed of light. In the quantum realm, the world behaves very differently from the familiar macroscopic world we experience every day. One of the strangest concepts in quantum mechanics is that of the false vacuum, a state that appears stable but is in reality teetering on the edge of a precipice. Imagine our universe like a ball resting in a shallow valley on a hillside. The valley represents the current state of our universe, seemingly stable and unchanging. But what if beyond the horizon lies a much deeper valley, a lower energy state? This deeper valley represents the true vacuum. The transition from the false vacuum to the true vacuum is not a gradual process but rather a sudden, catastrophic event known as vacuum decay. Imagine a tiny bubble, a minuscule region of space where the false vacuum spontaneously transitions to the true vacuum. This bubble, once formed, expands at the speed of light, converting everything in its path to the new vacuum state. Inside the bubble, the properties of the universe would be dramatically different, potentially destroying all matter as we know it. Chapter 6. Heat Death with Black Hole Era. The long goodbye of the universe. In the grand tapestry of cosmic time, black holes emerge as the ultimate survivors. As we venture further into the future, trillions of years from now, we enter the era of black holes. With the end of stellar formation, the universe will grow increasingly dark and quiet. Galaxies, once vibrant with starlight, will become ghostly remnants, their stars long extinguished. According to Stephen Hawking's groundbreaking work, black holes slowly evaporate over time, emitting a faint stream of particles known as Hawking radiation. Slowly, over unimaginable timescales, the universe will be populated by a thin soup of low-energy photons and elementary particles, the remnants of stars and galaxies long gone. Chapter 7. Quantum Collapse. A sudden end to the cosmic story? Quantum mechanics, the branch of physics that governs the microscopic world, is notorious for its bizarre and counterintuitive predictions. What if these strange quantum effects, usually confined to the subatomic realm, were to manifest themselves on a cosmological scale? The quantum collapse scenario explores the possibility that the universe could be inherently unstable at its core, susceptible to a sudden and catastrophic collapse driven by quantum fluctuations. Imagine the fabric of space-time itself as a seething sea of quantum energy, constantly fluctuating. These fluctuations are usually harmless, but what if a sufficiently large fluctuation were to occur, tipping the balance of the entire universe? This fluctuation could act as a seed, a nucleation point for a new quantum state, potentially rewriting the very laws of physics that govern our universe. Chapter 8. Boltzmann Brains, a universe of random minds. Prepare to enter the realm of the truly bizarre, where the line between reality and illusion blurs. This is the domain of the Boltzmann brain, a thought experiment that pushes the boundaries of cosmology, thermodynamics, and even philosophy. Imagine a universe governed by the laws of thermodynamics, where systems tend towards a state of equilibrium. In such a universe, over unimaginable timescales, random fluctuations in the quantum foam can give rise to incredibly unlikely events. One such event is the spontaneous emergence of a conscious entity, a Boltzmann brain, from the random chaos of a thermal equilibrium state. Imagine a fully formed brain, complete with memories, thoughts, and sensations, flickering into existence for a fleeting moment before dissolving back into the cosmic soup. Outro. The unending mystery of the universe. These theories, based on our current understanding of cosmology, quantum mechanics, and general relativity, offer a glimpse into the possible futures of our universe. From the slow fade-out of the Big Freeze to the sudden collapse of the quantum collapse, each scenario presents a unique and awe-inspiring end to the cosmic story. The true fate of the universe remains one of the greatest mysteries in physics, and only time will tell which, if any, of these theories will come to pass. Perhaps future observations and theoretical breakthroughs will reveal an even stranger and more wondrous fate than we can imagine. Thank you for joining us on this cosmic journey. Don't forget to like, subscribe, and share your thoughts in the comments below.